How's it going, everyone? Welcome, Julier Gonzalez here. And as you can see, there is I am a daytime, but unfortunately, it's a very cloudy day, and so far I don't have any light right now uh, in the place where I am because I still waiting for the handyman to actually fix that. Uh, if he can, I'll do it by myself. So in any case, so in the next 45 minutes, right? Let me actually count the time here. In the next roughly 45 minutes, I want to now explore is this chapter, the chapter 3 in JavaScript, all right? In terms of scope and closures. So the chapter 3 says, hey, the scope change. Chapter 1 and chapter 2 lay out down a concrete definition of the lexical scope and its part and illustrate helpful metaphor for its conceptual foundations. So if you remember what a lexical scope is the TLDR is that when you define your code in this scope that is determined at how now functions, variables, and block scopes, when the author defined them, they relate each other, and all of these definitions of the scopes happen is at compile time, aka at parsing or lexing part, right? And we say lexing because from the classical compiler theory we have now three phases. When the first is the parsing or lexing, the second is the abstract syntax tree, and the last is the code generation. So for the first, which is going to now tokenize or transform all of these different tokens into meaningful tokens for the language, right? So this particular process is known as tokenization or lexing, and it's subtle. The difference between lexical and lexing, or the tokenization and the lexing, is academic and very subtle. And it say, hey, if that particular token belongs to a next token or it is part of a following token. So this lexical scope, and we look at that in JavaScript, it the way how it analyzes the code behaves like a compiled language when it comes to analyze syntax errors and some early errors, as well as the hoisting. And it's in this last part of hoisting, this is when we look at the definitions of this function or the scope of these variables and functions and block and how they relate each other happens it at parse time. And also why it's important for us to understand this, what happened when we assign a variable to uh, some value, this assignment, and they call now this target or source assignment. It also lay out the foundation to describe or illustrate now how the lexical scope works by using metaphors. So these metaphors, which first is to define is now how variables fit or how variables fit in several in a particular scope, and how variables are available in that particular scope by using marbles and buckets example as well as bubbles, right? And when it comes to analyze to which variables this um, um, this to which scope these variables belong, all right, or to which variable to the when it comes to determine which variables this which variables belongs to a particular scope. This process is like having a conversation with first the compiler, with the scope manager that is going to now create these identifiers or this name for these variables, and then the second part, which is on the execution, is going to now between the JavaScript engine and the scope manager and say, hey, let me now assign this value to this identifier. It is important to know that this creation of these variables or these identifiers doesn't happen at compile time. In fact, it happens is when the code is executed. So it is important at least to understand, and the reserve is in memory happens is at execution. So it is important to understand that this JavaScript scope, it creates now a map of which variables belongs to which scope, in which are scope, and what kind of syntax generate now in the scopes. So for example, functions and block, and also for loops, right? And with that, now being able to describe some of these behaviors when it comes to lookup properties, or in this case, lookup for variables. So what happened when a lookup fail? And this is when we look at these reference errors. And what you're gonna do is to look up from the outer scope this variable, and if it's not there, it's gonna continue to look until there is a matching, or it reached the global scope and there is nowhere else to go. Or exactly, and then it reached to the global scope when there is nowhere else to go. So this particular scope change, which is now provided by this environment record or this lexical scope, right? That they have now is in its properties a reference to the outer and closing scope via the outer private method, the outerEnv. So this is now how this actually works. Okay, so but here we're gonna look at this. So chapter 1 and chapter 2 lay down a concrete definition of a lexical scope and its part, and illustrated helpful metaphor for its conceptual foundation. Before proceeding with the chapter, find someone else to explain, write or aloud in your own words what lexical scope is and why it is useful to understand, which is exactly what we did here. So the lexical scope is when you define your variables in related when you define the variables related to which scope they belong. All of these are determined at parse time, not at runtime, and they call lexical is because at that specific moment in the compilation phase that happened, right? So and why it is useful to understand that. So it is useful because since variables are one of the most important tool that we have in programming language to work with. So because functions are values and we can held in variables and use them, all right? So this structure, the scope structure, the lexical scope is defined, or it is association between the variables and the scope that which belong it happened is at compile time, and the structure is not modified by runtime conditions. So in other words, it means that you have now this scope structure that it won't modify by runtime conditions. There is something, there is a rule and a section to that rule by using is the eval, where you can modify that, but you shouldn't do that. In fact, don't use that. There might be some specific very edge case that you might use that, but most of the time you don't. So this is the reason why it is important to understand now the lexical scope and what is the lexical scope. So the lexical scope is allow us to define is the variables in related to which scope they belong at compile time. So, so the TLDR of that is that when you define at author time your code and the variables and where they belong, the scope structure is now determined at compile time. So, in other words, this is now how the closure is created. So that seems like a step you might skip, but I have found it really does help to take the time to reformulate this idea as explanations to others. That helps our brain digest what we have learned. Now it is time to dig into the nuts and bolts, so we expect that things will get a lot of more detail from here and forward. Stick with it. So because this discussion really hammers home just how much we all don't know about scope, yet make sure you take your time with the text and all the code snippets provide. To refresh the context of running example, let's recall the color illustration of the net scope bubble. For chapter 2, figures. So the illustration of this was, hey, we define is marble, buckets, and bubbles, all right, as a scope. Bubbles are scopes in these examples. Marbles are variables, and buckets are where those variables belongs to. So the connection between scopes that are nested within other scope is called the scope chain, which determines the path along which variables can be accessed. The change is direct, meaning the lookup move upward, onward only. Lookup is mostly contextual. In figure 2, notice the color of the student variable referencing the for loop. So for example here. How exactly did we determine that it is a red one marble here? Well, because we look up to the scope change, but particularly because any time that now a environment record is created, anytime an environment record is created, which is when you define a specific syntax form, whether it's the for, specifically whether it's a block or function or even the catch in the try catch, it creates now these records, right? That it is you can think of this record as like an object that has its internal properties. It's a pointer to the, or it's a reference to the outer enclosing scope. So in this case here, this block is say, hey, is a student here, which are part of this scope, do we have in this block? No, we don't. Okay, so let me look up to the outer environments to get that. So in chapter 2 we described as runtime access of a variables as lookup where the engine has to start by asking the current scope manager if it is known about identifier variable. Exactly, but this lookup for variables happening is at runtime and proceeding upward and outward, backward through the chain of nested scope toward the global scope until found, if ever. The lookup stops as soon as the first matching name declaration in the scope bucket is found. So the lookup process does determine the student in the red one. But this lookup process that is determined is now at the execution via the engine, all right? The association between this identifier with a variable happen is at compile time. So we have these two phases that happens here, right? So the lookup stop as soon as the first matching name declared in the scope bucket is found. The lookup process does determine that student is a red one marble because we have not found a matching variable name as we traverse the scope change until we arrive at the final global scope. Similarly, student ID like this is going to now look up this and say, hey, it create now the block scope is the actually is the one who create this block here. Is create this scope here and say, hey student, hey scope manager of the for of lookup, do we have this student ID? I have a source. Exactly, I have a source target. I have a source target called student ID. Do we have this at this level? No. So let me look up for the outer environment. And yes, we have that in the function block here, or the function scope here, like student ID. Okay, exactly. Similar, student ID in the if statement is determined to be the blue to marble. This suggestion of a runtime lookup process works well for a conceptual understanding, but it is not actually how things usually works in practice. The color of a marble bucket, aka meta information of what scope variables originate from, is usually determined during the initial compilation processing. Exactly, which is the color of a marble bucket, aka meta information of what scope variables originate, is usually determined during the initial scope processing. Because Lexical Scope is pretty much finalized at this point, a marble color will not change based on anything that can happen later during runtime. Since the marble's color is known from compilation and it is immutable, this information will likely be stored with, or at least accessible, each variable's entry in the AST. That information is then used explicitly by the executable instructions that constitute the program's runtime. In other words, engine from chapter 2 doesn't need to look up through a bunch of scope to figuring out which scope buckets of a variable come from. That information is already known by the scope manager. Avoiding the need for a runtime lookup is a key optimization benefit of the lexical scope. So this lookup for reference that now is defined at compile time, when the JavaScript engine needs to have access to the reference, it already knows what it is. The runtime operates more performantly without spending time on all of this lookup. But I say usually determined just a moment ago with respect to figuring out a marble's color during compilation. Mhm. With respect to figuring out a marble color during compilation. So in what case will it ever know will it ever not be known during compilation? Consider a reference to a variable that isn't declared in any lexical available scope in the current file. See get started chapter 1, which asserts that each file is its own separate program from the perspective of JavaScript compilation. If no declaration is found, that's not necessarily an error. Another file program in the runtime might indeed declare that variable in the shared global scope. So the ultimate determination of whether the variable was ever appropriately declared in some accessible bucket may need to be deferred to the runtime. Mm-hmm. But it's because when they collaborate, okay. So the ultimate determination of whether a variable was appropriately declared in some accessible bucket may need to be deferred to the runtime. Any reference to the variable that is initially undeclared, and by undeclared is that they haven't been uh, written, is left as an uncolored marble during the file compilation. This color cannot be determined until all the relevant file has been compiled. Any reference to a variable that's initially undeclared, and by undeclared is okay. This color cannot be determined until all the relevant file has been compiled and the application runtime commences. That deferred lookup will eventually resolve the color to whichever scope the variable is found, in likely the global scope. However, this lookup will only be needed once per variable at most, since nothing else during runtime could later change that marble color. The lookup failure section in chapter 2 covers what happens if a marble is ultimately still uncolored at the moment it is referenced is runtime executed. Which is, hey, I throw now a reference error that this is undeclared, that this is undefined, aka is not being declared. Shadowing. Shadowing might sound mysterious and a little bit sketchy, but don't worry, it is completely legit. Our running example for this chapter use different variables named across the scope boundaries. Since they all have unique names, in a way it wouldn't matter if all of them were just stored in one bucket, like red one. We're having different lexical scope buckets. So our running example for this chapter use different variables names across the scope boundaries. Since they all have unique names, in a way it wouldn't matter if all of them were just stored in one bucket. Okay, like red one. Where having different lexical scope buckets start to matter more in when you have two or more variables, each in different scope, with the same lexical names. So far we have looking at examples where each one of those variables have the same, have different names in different lexical scope. But when you want, but what happened when you have now variables with the same variables with the same name in different scopes? Okay, such multiple reference will be assumed as just one variable. So if you need to maintain two or more variables or the same name, you must use separate of the nested scope. And in that case, it is very relevant how the different scope buckets are laid out. So if you need to maintain two or more variables of the same name, you must use separate of the nested scope, and in that case it is very relevant on how different scope buckets are laid out. So for example here, hey, if you want to need to have that different scope, all right, exactly. If you somehow find yourself with in the need to have declared variables with different scope, this is how you might have this. The other is a student name. Student names to uppercase and console.log student name. Print student Frank, and print student Frank student name and console log student name. Print student Frank, Susie, and Susie. So print student, and then you got it. Frank and the student name in here. So hey, print Frank, what'll be this print student with student name. If you pass now this, you're gonna pass now Susie and say student name to uppercase with all of them as Susie. If you now console.log here student name, is gonna take that reference here. Before you move on, take time to analyze this code using various technique metaphor we have covered in this book. In particular, make sure you identify the marble bubble color in this snip, which is a good practice. So we got the global scope, right? And here we also have is the function scope. So because now this function scope, it is like this, okay? And what's happening here, it's say, hey, when you call this, when you call this function, I'm going to pass as an argument Frank, and going to be assigned to the student.name, which is now a student reference. So in other words, it's say, hey, the compilation and the assignment is this. So on the compilation, it say, hey, hey scope manager, I have a student name identifier. Do we have them? No, we don't have. Let me create that in the global scope. Hey, I have now, hey scope manager, I have now the print student functions definition identifier. Do we have them? No, do we haven't? Let me create that. All of this is just definitions. And when it comes now to the execution of the code, it's a hey, hey engine, scope manager here. I have now this assign, hey engine, I have now an assignment here to the student named identifier. Do we have them? And the scope manager say, hey, yes, here we are. All right, now let me assign is this variable to the identifier. And it's going to analyze here and say, hey, engine scope manager here of the global scope, do we have now a print student identifier? Yes, that we have. All right, because I want to now assign is the arguments with this value here, and then execute the function. So when this function is executed, it creates now a function execution context, all right, that when that is created, it has now the student name with the value Frank, the student name which holds the same reference here, and say, hey, let me uppercase that, and then now console log that. And when you define in any all functions returns undefined, so it's gonna not only execute this, show you Frank with uppercase, but also is return now undefined. The same for this. Hey, scope manager here of a global scope. Do we have this identifier engine? Because I want to now is assign the value from this source reference. And they say yes, we have them. And here you say, hey, scope manager. Hey, this is a scope manager here again. The engine. Do we have now this console identifier? Yes, we have. And the log exists inside of this console log. Or is this identified inside of the console log exists? Yes, it does. All right, let me now pass this reference to that. And then execute that code. So the student name variable on line 1, the var student name equal create is a red marble. So exactly, here is creating is a red marble, and the same name variable is declared as a blue 2 in the marble line 3. So the parameter in the print student functions definition. So what color marble will student be in the student.name uppercase assignment? Well, it is the blue, which belongs to this particular scope. All three student names in this reference will be blue. With the conceptual notion of lookup, we assert that it starts with the current scope and work it is outward and upward, stopping as soon as the matching variable is found. The blue 2 student is found right away, and the red 1 student is never ever considered. This is a key aspect of lexical scope behavior called shadowing. So the shadowing is when variables in different scopes. The shadowing is when variables with the same name in different scopes are resolved exactly. So the resolution of variables reference with shadowing is when you have shadowing is variables with the same name. Okay, shadowing is variables with the same name, a different scope. They will be resolved they will be resolved as just one variables, the first it encounters. So the parameter is shadowing the shadow global variables. Okay, so shadowing here is in the lexical scope is when you are like overriding the reference here when you have now several variables named. So that's why the reassignment of a student affect only the inner parameter here and not the global red one student name. So when you choose to shadow a variable from another scope, one's direct impact is that from the scope inward and downward through any nested scope, it is now impossible for any marble to be colored as a shadow variable. Red one in this case. In other words, any student identifier reference will correspond to that parameter variable, never the global student name variable. It is lexically impossible to reference the global student anywhere inside of the print student function or from any nested scope. Global unshadowing trick. Please be aware, leverage the technique I'm about to describe is not a very good practice and is limited in utility, confusing for readers of your code, and likely to impact bug on your program. I am covering it only because you may run across this behavior in existing programs, and understanding what's happening is critical to not getting tripped up. If it is possible to access a global variable from a scope where the variable has been shown, but not through a typical lexical identifier reference. In the global Okay. In the global scope, Red 1, var declaration, and function declaration also expose themselves as properties of the same name as the identifier on the global objects, essentially an object representation of the global scope. If you have reading JavaScript for the browser environment, you probably recognize the global object as window. That's not entirely accurate, but it's good enough for our discussion. In the next chapter, we'll explore the global objects topic more. Consider the program specifically executed as a standalone JavaScript file in the browser environment. So where you are here now accessing to that global unshadowing trick to that variable. And notice that Windows student name reference. This expression is accessing the global variable student name as a property on the window, which we are pretending for now is synonymous of the global object. And that's the only way to access a shadowing variable from inside a scope where the shadowing variable is present. The window.studentName is a mirror of the global student variable, not a separate snapshot copy. Chains to one are still seen from the other in either direction. You can think of window.student as getter and setter that access the actual student name. Remember, just because you can doesn't mean you should. Don't shadow a global variable when you need access to conversely to this. This little trick only works for accessing a global scope variable, not a shadow variable from a nested scope. This only works for global scope variables, even though the only one that was declared with var or functions. Other forms of global scope declaration do not mirroring global object properties. And variables, no matter how they are declared, that exist in any other scope, that the global scope are completely inaccessible from a scope where they are being shadowed. So special 42 function looking for special, for example here. So the global red special is shadowed by blue special parameter, and the blue and the blue 2 special is itself shadowing by the green special keep looking function. So we can still access the red one via the window object. Exactly. But there is no way for keep looking to access the blue special that holds the number. All of this. Copying is not accessing. I have been asked the following, but what about question dozens of times considered? This one. Okay. If you hold now, copying is not as accessing. So if you define now instead of this, right? Instead of this, so what you are now creating is a copy of that, but at runtime. Oh, so does this another object technique disprove my claim that the special parameter is completely inaccessible from inside? Keep looking. No, the claim is still correct, because no matter, oh, tricky. Special is copying the value of a special parameter or variable into another container. Which means that you don't have access to that ref. But that doesn't mean we are accessing the parameter special. It means that we are accessing the copy of the value and it had at that moment. By the way, another container object property, we cannot reassign the blue special parameter to a different value from the inside. Keep looking. Another bot, you may be about to rise. What if I use object or array as value instead of a numbers? Will us having reference to object instead of copy of primitive value fix the inaccessibility? No, mutating the content of an object value via the referencing copy is not the same thing as lexically accessing the variable itself. We still can reassign the blue to special parameters. Illegal shadowing. Not all combination of declarations shadowings are allowed. Let can shadow var, but var cannot shadow let. Okay, so var cannot shadow let. Totally fine. Totally fine. Let can shadow var, but var cannot shadow left because okay. Okay. Let can shadow var, but var cannot shadow let. Notice in the another function, the inner var special declaration is attempting to declare a function y special, which in and itself is fine, as shown by the something function. The syntax error description in this case indicate that special has already been defined, but that error message is a little misleading. Again, no such error happens in something, as shadowing generally allow just fine. The real reason it is raised as syntax error is because the var is basically trying to cross the boundary. Because when it's trying to analyze this, it say, hey, var is not block scope, it is function scope, aka that variable is now, which is hopping over. The boundary crossing provisions effectively stop at each function's boundary. So this is this variant raised no exception because this is a function here. Summary: let in an inner scope can always shadow an outer scope variable. Var in an inner scope can only shadow an outer scope let if there is a function boundary in between. This is to describe now the shadowing it and the illegal shadowing. Function name scope. If you have seen by now a function declaration like this and discussed in chapter 1 and 2, such a function declaration will create an identifier in the enclosing scope. In this case, the global scope named ask questions. What about this program? The same is true for variables ask question because it creates now, but it is a function expression. A function's definition use as value instead of a standalone declaration. The function itself will not hoist. One major difference between function name scope. So it talking about is the lookup, the shadowing, what it means, the shadowing, the legal shadowing, and the function name scope. So The function's declaration actually creates an identifier and it is enclosed in scope. Exactly. And it is enclosed in scope. But and it is hosted, but a function expression will not host. And one major difference between functions declaration and expression is what happens to the name identifier of the function. And consider a name function expression like this. We know ask question ends up in the outer scope, but what about of teachers identifiers? For formal function declaration, the names identifiers end up in the outer and enclosing scope. So it may be reasonable to assume that that's the case here, but of teacher is declared as an identifier inside the function itself. So if we're trying to have access to that, we say the function is a function of the teacher. And if we can have access to that reference, what? Actually, of teacher is not exactly in the scope of the functions. Appendix 8. It implies a scope. We'll explain further. Not only if of teacher declared inside of the function rather than outside, but also defined as read only. Because we use a strict mode, the assignment failure is reported as a type error in the non-strict mode. Okay. That'll be all for this video. Take care. Bye bye.